very, very distressing news. Recently, we were fighting a wildfire that was not in Prescott, however, it was in Arizona. Typical of a fire like this, we send many crews from all over the state. The wildland crew from the city of Prescott, Arizona was deployed to that, and as a result of circumstances that I'm not aware of or have not been informed of yet, our entire crew was lost. We lost 19 people in this wildfire.
Weighs a few pounds, but it could be the key to preventing a small brush fire from turning into a big one. A high-flying firefighting tool is making its debut in San Diego, and 10 News reporter Michael Chen is showing us how it could give fire crews the upper hand.
Now, unmanned aerial vehicles, or drones, may be flying into a different firefight.
We absolutely know that it could be a difference maker.
Meet the Cube, a 5-pound, 4-rotor drone making its debut at a firefighting convention in San Diego. It's made by AeroVironment, which owns much of the military drone market. The biggest edge of the new drone is this.
They can have this out of their car or truck and into the air in 5 minutes to do a quick assessment.
This is video shot by one of the company's drones of a controlled burn during a recent test done with the U.S. Geological Survey. Quickly, the drone's thermal cameras can zero in on hotspots, how the fire is behaving, and where the fire is moving.
At the very start of something like that, is when we have the most ability to stop it.
A live feed of the fire can be viewed remotely by many eyes, which will help in quick decision-making.
In the future, houses will have many sensory devices to detect fire, toxic materials, anything that may threaten the life of a human being. Now, if you walked into the house of the future, you might say, "Can I use your phone?" So what's a phone? No, you just say, "I'd like to talk to Sam in Arabia." What part of Arabia? You just announce what you want, and the sound will be focused at some point instead right at your ear. So you can hear Sam in Arabia. In southern Florida, millions of dollars in buildings were destroyed by the big hurricane there. And they put up buildings that look just about the same. Now, if you don't want hurricane damage, an inverted cone, it's almost impossible for a whirlwind to pick up an inverted cone. So we would have these shelters built in the West Indies or wherever hurricanes occur. And inside would be pull-down bedding, food storage, and emergency water. So this is the kind of form that no vortex or wind can pick up. Try to pick this up with greasy fingers. And that's similar to the wind whirling around it.
Cars that drive themselves, not just found in sci-fi movies, apparently. The technology is out there and companies are testing it behind the wheel. Here's what you have in this week's Technovations.
The 1980s TV show Knight Rider featured KITT, the self-driving car.
The car just drove around the truck and steered itself.
Driverless cars are no longer just on TV or in the movies. The technology is actually closer than you think. Google has the first driverless car approved to be tested on state roads, and it can literally drive itself. The car sees what's around it using GPS, a spinning laser scanner, cameras, and radar sensors. Continental Automotive is also another company designing a car that can drive on its own, but drivers make turns and change lanes themselves.
You're much more relaxed when you're driving this car because you are still monitoring, but you're not working on the driving task itself.
This car steers, accelerates, and brakes all on its own using radar sensors and cameras that give it almost human-like vision.
We are looking at the street with 2 eyes, in this case 2 cameras. So it's very similar to what your brain is doing.
Self-driving cars could be on the market in 5 years. They're designed to make roads safer and decrease the number of accidents.
When you're in a traffic jam, people get distracted. But we strongly believe by adding the computer vision, the radar sensing, that supports the driver and makes the car safer.
Most people don't know the answer to this question. When you look up in the sky at night and see trillions of stars, how many of them are from inside our own galaxy, and how many of them are from other galaxies? The answer is, all of them are from this galaxy alone. All other galaxies appear as but a speck in the distant cosmos of space. Nuclear physicist Michio Kaku refers to a classification system for alien civilizations based on a Type 0, Type 1, Type 2, and Type 3 graduation scale, 3 being the most advanced. This would be a civilization with intergalactic capabilities. This means they have the technology to travel to other galaxies. A Type 2 civilization is one that has mastered interstellar space travel. This type can leave their home star and begin colonizing other stars within their own galaxy. A Type 1 civilization has mastered interplanetary space travel and control of the Earth itself. Type 1 is able to sustain a habitable environment on Earth and in space. Type 1 has switched to clean renewable energy, while Type 0 still relies on fossil fuels for energy and transportation. Here on planet Earth, we will remain Type 0, as long as we rely on hydrocarbon fossil fuels for our way of life. Before I can even begin to talk about all the really cool stuff that would exist in a Type 2 or Type 3 civilization, we have to concentrate on how to make the most crucial and difficult step of all, from Type 0 to Type 1. In physics, every single thing in the universe, including people, do only two basic things. They move and they interact. Physics is the study of energy and motion. Motion is half of physics, which makes it half of everything that anything physical ever does. Transportation is half of what people do. They go places, and the technological capabilities of our transportation systems themselves is half of what defines us on the scale of civilizations. The other half is energy and information capabilities. The Internet is a Type 1 information system, which has a telephone and library built into one. The Internet is our first step towards this rather difficult graduation from being a Type 0 to being a Type 1. In the galactic neighborhood, it means the difference from being a complete zero to actually being someone. Type 0 global transportation systems rely on passenger jets, which use kerosene, a hydrocarbon fuel, for energy. A Type 1 transportation system is similar to what you've probably seen on Futurama or other depictions of futuristic worlds, a tube-based transportation system. Similar to the pneumatic tubes at bank drive-thrus, but different. The Type 1 global transportation system can go much, much faster. It's called an Evacuated Tube Maglev Transport, or ETT for short. Evacuated tube transportation technology is actually a patented, readily engineerable technology which is ready to be implemented into our society with current existing off-the-shelf technologies. Maglev bullet trains are already in use in Europe and Asia. These trains go 500 to 600 miles per hour and are only limited to going any faster by the air resistance and sharpness of the turns that they take. However, if you cover the track with a tube and suck out all the air, you get an evacuated tube with no air to cause resistance. The next trick is to get the capsule to levitate in the center of the tube. This can easily be achieved via the Meissner effect, by which superconductors expel magnetic fields, causing them to levitate magnetically. The last final step is to make ultra-straight guideways. Since we're bound by Newton's laws of motion, we have to take them into account. Force equals mass times acceleration, which means that we only feel a force when there is an acceleration that goes with it. Acceleration is just a change in velocity, so you can only really feel a force when there's a change in velocity. When you step on the gas pedal in your car, your velocity increases. This is why the gas pedal is sometimes called the accelerator. When you're traveling in a car going 70 miles per hour, do you feel any different than you do standing still, other than the vibrations from the tires on the road? What if you gently apply the brakes and lower your velocity? You may feel a tiny force. But if you slam on the brakes and lower your velocity very quickly, you'll feel a much bigger force. This is because there was a larger change in velocity, which equals a larger acceleration, which equals a larger force. You can't feel a velocity. You can only feel a change in velocity. So there's nothing preventing us from traveling 4,000 miles per hour as long as we don't change that velocity too quickly. In fact, spaceship Earth is orbiting the Sun at tens of thousands of miles per hour right now, but due to the laws of relativity, we don't notice anything. Turning requires a change in velocity, which is known as centripetal acceleration. If we multiply this acceleration by a mass, we can get a force. The force of gravity is 1 g of acceleration, and humans can endure 1 or 2 g's comfortably as long as the direction of acceleration doesn't change too rapidly up or down. Roller coasters reach as high as 5 or 6 g's, but not everyone enjoys riding them as much as some. So in order for passengers to ride comfortably on ETT, we need to place this constraint on the forces in our equations to tell us how large our turning radius needs to be based on our velocity. And as long as we make the tubes straight enough, we can go as fast as we want through them, traveling safely at thousands of miles per hour, faster than jets ever could. At such incredibly high speeds, we can also increase the frequency of traffic, which equates to an 80-lane superhighway fitting inside a single tube. The system would be completely automated, so there would be no backups or delays due to accidents or human driving error. Egg factories handle millions of eggs per day using automated machines, which break far less eggs than human workers would otherwise. Computer automation is what allows Homer Simpson to run the entire Springfield nuclear power plant from a single chair. Of course, he's just a cartoon character, but you get the idea. 40,000 people die each year from automobile accidents in America. That's 115 a day. Automated mass transportation systems not only save lives, but they completely eliminate stoplights and traffic jams. Imagine living in warm, sunny Los Angeles and commuting daily to New York City with only a 45-minute commute. Imagine ordering Chinese food from China. Imagine 2-hour worldwide travel on demand at a fraction of the cost of an airline ticket. I can't even begin to list the benefits this type of transportation system would have on all aspects of human life and interaction, our economy, society, and world peace. Just think, an ETT backbone stretching across the US, up through Canada, Alaska, over the Bering Strait, down through China, across India, up through Europe, and finally to Britain. It would connect all the world's major population centers, free us of our addiction to hydrocarbon fuels, and could run completely on renewable solar and wind energy, built along the infrastructure of the track itself. Windmills could run vacuum pumps, while superconducting rails could transmit global electric power far more efficiently than high-tension wires. There's also the idea of pumping liquid superfluid helium through the tubes to provide the superconducting component required to achieve magnetic levitation. This would be easier than pumping liquid nitrogen across superconductors, although there's still a great deal of debate on how to best engineer the ET3 system. Nanotechnology allows for all sorts of advancements in construction and material science. Ductile concrete is nano-engineered concrete, which is designed to set without any gaps, air pockets, or uneven spaces in the concrete. As a result, it is much stronger than regular concrete and can allow for new design implementations based on its incredible strength. Another possible application of ET3 would be the construction of a space ramp, which accelerates capsules and launches them into orbit. Build the ET3 up the side of a mountain like Mount Everest. This would replace NASA's space shuttle program and the costly, archaic, and dangerous rocket engines which are currently used to reach space. ET3 systems could be set up which retrieve and recycle the kinetic energy from objects entering the Earth's atmosphere. Mining asteroids would harvest material and energy beyond the limitations of the diminishing natural resources of our planet. Some people have suggested nominating the Internet for a Nobel Peace Prize, since it has done more for world peace than any human being by giving people a conduit through which friendships and collaborations could be established as never before. Evacuated tube transport would provide the same interconnectedness as the Internet by expanding it into the physical realm, building bridges instead of building walls. What a concept. Imagine not being limited by location or distances. Imagine scientists being able to freely travel to go to work on research projects which are taking place halfway around the world from where they live or study. Evacuated tube transport is comparable to the London Underground or the Transcontinental Railroad, and just like these transportation revolutions of the past, it has the potential to lead the world out of the current economic conditions by boldly creating unprecedented environmental, social, and economic returns. This brings forth new possibilities for expanding the allocation of prosperity to all people of the world, and better nurture the self-sustainability and protection of the human race. Don't forget to check out et3.net, and let me know if you have any other ideas or technologies that could help humanity progress towards a